There is an authority to share here.
You can
have that.
Yes, you can share. You can share by yourself there, down there, I think.
Share screen. Okay, share screen. Okay. Okay, assalamu alaikum and good morning for everybody. We are going to share some of information about time value of money today. Inshallah, my learning objectives will be inshallah achieved. Maybe I have determined some learning objectives, like you will get inshallah the understanding about time value of money and its other components like simple interest, compound interest, annuities. We have present value, future value, and perpetuities, and the link between time value of money and value of the firm. Beginning, we start with the time value of money concept. So it is important to recognize that the dollar today is value more than dollar in the future. And any some point in the future, dollar will be less than dollar today, than the value of dollar today. So we have so many obstacles that make dollar less in the future. Here, we will explain three of these problems that makes dollar less in the future. We have the opportunity cost. That's if you have now your $100 or $100,000, you want to buy a car right now. In the future, you will not be able to buy the same quality of that car. So maybe you will buy a less quality, or you will be buying maybe motorbike or something like that in the future because of the inflation. The purchasing power will be changed in the future. The 100,000 that you want to use it for buying a car today will be not valuable to buy the same car in the future. This one we call it inflation. Inflation is just a problem of monetary policy with the bank, with the central bank. The problem is they push just some money to the market without any goods and products that the country produce some goods and other services. So there will be so much money in the market and less goods instead. This is the inflation. So purchasing power will be changed during the over time. Here we have an example for 1,000 today. It's worse than the exception is of 1,000 tomorrow. Here we have explained the inflation. Uncertainty also. For uncertainty, it's just to if someone offered you to get $100 today, and he said you are going to get $100 and one after 1 year. Here you will not be accept to get the $100 and one after 1 year because it's nothing. $1 is nothing to wait for it. So if he said 110, you will say, okay, maybe it's worse, but there is no certainty to get the $10 after 1 year. Here, this also the risk of certainty of the risk of uncertainty to get the money after a certain time of period. For also for investment, I said that the investment is also related to opportunity cost. To wait for the money, if you deposit your money in the bank, so you have to wait for the money to be to be earned some interest rate or based on interest rate number, maybe 10%, 20%. So you should deposit your cash to the bank to invest it to earn the interest rate, to earn the interest amount in time of period. Here we have two types of interest rate. Interest rate to invest your money to get your investment, your initial investment today, you invest it, and to get in the future to get your money plus the interest amount. We call that is future value. Today we invest our dollar, and then we get $1 and plus to the amount of interest after a certain time of period. The second, this one we call it compounding for future value. The second one we call it interest rate discounting of interest rate. This one we calculate the present value of money for this one. How much we invest today to get $1 in the future. How much we invest today to get $100 in the future. This one is the present value of money to discount the future value until today. Okay, so we have here two terms, compounding and discounting. Compounding is related to future value, and discounting related to present value. Yes, also for the difference between simple interest and compound interest. This is very important also to know. Simple interest is the very simple. It's just to invest your deposit, the initial deposit. We call initial deposit, initial investment. It's also principal. We call principal P. Principal P here. We invested or we deposited to the bank to get, if it's simple interest now, we call simple interest. It's equal to principal multiplied by the interest rate or simple interest rate plus multiplied by also the time of periods. It's also here, it's common, it's year, like 1, 2 years, 3 years, annually basis here. So we multiply by principal, multiply by interest rate, and multiply by the time of period. Then in the future, you will get your principal plus the interest amount. The interest amount. After 1 year, we say maybe your initial deposit is 100. After 1 year, it will be 100. After 1 year, will be 110. If you got 10% from the bank, 10% interest rate, so you will get 110. Here we have 3 years, so we will get $130. $130. Each year we have $10. So it's like fixed interest each year. $10 each year. For this way, you know, it's look like here the formula. It's one here. It's represent to the 100, the 100% of the initial investment or initial deposit. The 100% is 1 here. 100% of the initial investment plus interest rate multiplied by time, the time of period, maybe 3 years here, 3 years. So the result here 150. This one is the formula for simple interest. We will check for compound interest also. Here, compound interest, the term of 1 plus R or 1 plus interest rate. This one is I told you this is 100% plus the certain of interest rate bank will give you. So here we have each year we have this term 1 plus R each year multiplied by the second year 1 plus R multiplied by the third year 1 plus R. So we have 1 plus R multiplied by 1 plus R multiplied by 1 plus R. This will be an exponent. The time of period will be an exponent here, not as we told you here, multiplied by the rate. So the exponent will be represent to the time of periods here, 3 years. Look at the difference here. The difference will be 100, 1 plus 10% interest rate to the power of 3. To the power of 3 will be equal to 153.1. It's more than 101. This one is the difference between compounding and the simple interest. Compounding or compound interest is more than, because we invest also every year. We invest interest earned. The interest earned every year here $10. We invest it in here again. Okay. So there is also something else. The intra-year interest rate. Interest rate here compound annually. Look at this, or compound monthly, compound quarterly, or semi-annually, weekly, whatever the intra-year, inside the year, how many periods inside the year, intra-year interest rate. So we have also here how to solve it. Here, the I will be equal, we say I is the interest rate, will be equal to R divided by M. R over M is the interest rate represent to the intra-year interest rate. This M equal to the period per year. How many periods? If we say semi-annually, how many periods do we have? We have 2 periods during the year. Semi-annually. If it's quarterly, we have 4. So I will be equal to the rate, maybe 10% divided by 4. Also, monthly, how many periods, how many months we have inside the year? We have 12. So will be R divided by 12. Then we have also to use M to multiply by the T, for the time of period. M will be also multiplied by the time of period here in the exponent. Must be also multiplied by the 3. If it's monthly, if it's monthly, we will say 12 multiplied by 3 here. This one is very important also, will be considered in our examples later. Here also, the compound interest formula, it looks like that after we add the intra-year interest rate. Look, this one is I. This term is I. It's equal to R divided by M, or R over M. And also the exponent will be changed and to be M times T, what we call it N, or number of period. N of period will be M times T. Okay, we will start explaining the future value and present value. As we said, the money today is less valuable than, more valuable than money in the future. More valuable. So that's because we are waiting for there is opportunity cost waiting. To wait for future to become, so the money will be changed. The power purchasing power and other things will be changed. Here, for future, you will deposit your initial deposit in the bank. You will get the compounding interest rate. Then you are going to receive more money in the future. The money in the future will be according to the I or interest rate. How much interest rate you have? You got maybe 20 interest rates. You will get better amount. If it's interest rate 10%, will be lower, and so on. For present value, we will discount. We will discount the interest. We call it discount from future until now. How much we should invest today to get this amount in the future? How much we should invest today to get maybe $100 in the future? If we have 10%, we should invest. We have an example. If we have 91 now, if we invested for maybe 1 year, with at 10% interest rate, so in the future we will get 100 in the future. This one is future value. The 100 here is the future value, and 91 is the present value. This one is the amount we have invested today. We have deposited to the bank today. So in the future, we will get the $100. Here also, we have here the intra-year interest rate. Here, 6% per year compounded monthly. If it's compounded monthly, that means the time of periods will be changed, and also interest rate will be changed. Interest rate is equal to 6% over 12 months per year. Also, T times 10, we said T 3 years, here 3 years, times 12 per year. So it's going to be 36. Okay, here 36 periods. Here also we get the result for the 36 periods, and also for the I interest rate equal to 6% compounded monthly. Okay, in the future we will 20,000. Now we should invest 16,713. 16,713. Here we have annuities. What are the annuities? Annuities is a sequence of payments or series of payments made at regular time of period. Like, we have to consider this annuity as a as a equal amount deposit to the bank, or got from bank, as you like. We consider it as equal and are equal amounts periodically receiving from the bank or deposit to the bank periodically. So we have two kinds of annuities. We have ordinary annuity and annuity too. Also, the difference between them is to the payments. When the payments deposited to the bank at the end of the period or at the beginning of each period. If it's the end, we call it ordinary annuity, or we call it annuity. Annuity also, we didn't say ordinary, it's annuity. Here we call it annuity. So at the end of each period, we call it annuity. At the beginning of each period, we call it annuity due. Okay, we will explain this, and we will also apply the future value and present value for each annuities, for all annuities, We have here an example. If we have 1,000 each year at 8%, each year 1,000 deposit to the bank, maybe like that. At 8%, how much would you have after 3 years? After 3 years of this annuity to be deposited to the bank, after 3 years, we will start by the second year. We will start by the second year, and then present value for the second year. Maybe you can solve this one as an individual separately. Then the another one for the first year, and this for year 0. For year 0, it should 1 plus r here to the power of 0. To the power of 0, it's equal to 1. So it's equal to 1. So present value multiplied by 1 is equal to the same amount. So here we have future value equal to this 1,000 plus 1,000 plus 1 to 3. So if we have the interest rate 8% will be 3,246.40.4. This one is the first example for the annuity. The other example, 100 each year at 10%. How much would be after 5 years? After 5 years, we also use the same. We use the first year of the fourth year separately, third year, second year, and first year. Then you find 610 after 5 years. This is because 5 years we have 610. So here we add all these amounts to each to others. Here we have 146, add plus. We have to also plus 100 that we have to here. We invest 100 and receive. We invest and receive, so there is no any compound interest here. So we add also 100, 610.51. Okay. I think I forget to show you some we have here. Here also I forget to show you the here difference between simple and compound interest, and we have also the annuities. Here the difference between graphically between interest, future value, and this is the future value, and present value. Present value will be discounted, as you see, from future until today, and future value from now to future. So how much will be the amount in the future, in some point in the future. This you have. I will send to you, the moderator. What else is the compounding? The compounding for present value, the discounted for present value, and compounding for future value is look like that, as we have here in here for annuities. Now, if we have here, if we have a different payment each year, so we should use this way. We should use this way to find an annuity. An annuity with the different payment, we should use it as we see now. 100 something, 300. So if we have a different payment, so it's also similar, will be similar to this result. But if we have same amount, equal amounts each period, the very good formula to use is this formula to use for different, for similar or same payments. equal payments each period. We have future value annuity, future value annuity, S for annuity. Payment here maybe 100. Here we have 100. 1 plus I. It could be intra-year interest rate. Could be intra-year interest rate, like compounded quarterly. Here we said compounded quarterly. So I. N, the time, number time of periods. It could be periods like year or other periods like months or something like that. So it multiplied by this one N is equal to M multiplied by T. T, yes, years annually, but M is the number of periods that we determine here. So compounded quarterly means how many quarters per year? We have 4 quarters. So it's just 4 multiplied by T, and I, which is 8%, divided by 4, minus 1. Minus 1, here 1, we said it's represent to the, here also 1 represent to 100% of the amount, 100%, minus 100%. So after we add our investment amount, it could be investment amount is there, then minus 1 minus the 100%, divided by the also same the interest rate, I interest rate. Then we will find here the result. It was 100 each year, each quarter of year. We have 3 years. So we have 3 years. We have means 12 periods. Periods is going to be 1,321.21. This is the result. 1,321.21. Result of unity of 100. Another example for an annuity using also 112% compounded monthly. Here we compounded the 12% monthly, so we use future value of annuity. Annuity, we have payment 100, and as we explained, the 100 the MT will be equal to 12 months, because monthly 12 multiplied by time of periods. How many years we have? We have year. We have how many years here? 1 year. Per year, 1 year. We have just 1 year, so 12 multiplied by 1 is 12. Will be equal to 1,268.25. Also, this is the future value of 100 after 1 year compounded monthly. Each month payment paid. Each month paid. Okay, and we complete the future value. It was future value for an annuity. We start present value for an annuity. Present value of 1,000. Here we will use the discounted interest rate from the future until now, until today. So we have here 3 years of interest rate of 8%. Present value will be equal to, you know, the present value for lump sum. For lump sum is like this. The flow for payment divided by 1 plus I. Here also the N or time or number of periods. This one is for lump sum, for the single amount. The plus second period plus third period. So we discounted to the 1,000 each year for 3 years. It's supposed to be 3,000 something, but here we discounted until 2,500 discounted until now. So it's now the money now 2,577. So we invested to be 3,000 something, 3,000. If we also consider that there will be more than 3,000. So it is very easy for annuities. We have now similar amount. If as we said, if they are not similar, if they are not same, so we will use this formula. This formula is to take each amount separately, so we will find easily the result. For equal amounts or equal payments, we will use the another formula here, as we will explain. Now also similar, we have also same example to invest or to discount the 165 years from now. How much it was now? 379.08. This one is the amount now we invest for future, and we have here the same things. We just use all of these similar or equal amounts, and we found the result. We here just add amounts to each other to find. It's easy. It's very easy. Here it's a little bit complicated, but it's also easy. We can also use Excel to find. I will show you how to find it in spreadsheet Excel. Same. We have 100 payment each month. Compounded monthly means each month at interest rate 9%. We have also interest rate 9%. It's going to be 0.09 12 months period. Here we got this up. It wasn't down here. 1 plus I. Look here. It's down here in this formula. If we just use this one to be in the numerator, this is denominator. It's going to be in the numerator. Will change the exponent. Exponent sign will be changed. Exponent sign here will be negative. It was positive down there. Now exponent is going to be negative because we got this up. You know, this is a mathematical rule. 1 minus it's different than, look at, if you look at the future value minus 1 after finish doing the term of 1 plus I, then here 1 minus, because here we discounted the amount or the amount of payment discounted until now. So 1 minus the term of 1 plus I. Also the number of periods are negative. Here also similar, but we just open this I to be R divided by M because we need to compound it monthly. So the result here is 21,000 to 2,188.91. The result for 100 compounded 2 years from now. Okay. Discounted 2 years. Discounted 2 years from the future until now. Also another example for present value or an annuity consisting of 3 years. Every single period we have 4,800. They said each month means 12 per year, 12 periods per year. So we also explain it as we explained before. We got the present value. We discounted from the future. We will show you the Excel for future value and present value. How we do it. For future value here, future value we use the same. The present value, this one, present value means the initial deposit or initial investment, or we say maybe your investment, your initial investment, your principal. We can say principal also same. Present value at 3% interest rate invested and for 5 time of periods. We say maybe years, maybe. Also 5 time of periods. This one, if we use a calculation using formula, we will use this formula. Look at this formula, it's similar here. Present value or initial deposit multiplied by 1 plus I, which is 3% to the power of 5, to the power of 5, which is n. So we use this formula as I show you here in there. For future value formula, present value plus similar. Also in the beginning we have it here, same future here also the future value formula. Future value formula is this one. So we just apply in Excel, same formula in Excel. We can also do it. R divided by M if you have intra-year interest rate. If you have intra-year interest rate, you will use the 3 divided by M, 3% divided by M, and also you will also change the time of period 5 will be multiply M multiplied by the number 5 or T. So now here we have here an Excel function. If you see future value equal to we have to add the rate here. Just click the rate 3%. Number of periods 5. Number of periods. Payment here we don't have payment. We have just present value. We don't have payment. If we have payment, that one with annuity. We can use with an annuity. Yes, we use payment. Now we use present value. Then we use also for type 0 because it's in the year of 0, starting in the year of 0. Okay, now it's equal to same amount 900. Here the sign will not be considered because here they consider for the function of Excel, they consider this present value as an outflow, not in cash flow. Out cash flow, it must be negative. So if we use this, if we put negative here, this will be positive. So it's supposed to be negative, but we consider this amount as a positive right now. This one is because of you have to put negative in your out cash flow. It's supposed to be negative. So here I explain the negative sign of the function of Excel sheet, spreadsheet Excel. Here we have also future value. For future value, same. We use the function of future value, present value. Same. Here we have divided by the term of 1 plus I to the power of 3. To the power of 3, we have here 6% here, 6% in here. If we have any intra-year interest rate, so we add M. We divide it here, we make it over M, I over M, or R over M, and then multiply by T, M multiplied by T in the exponent. It's easy. Here we have now we discounted the present value. It's equal to 1,400 something, 127.3. So here we can make it. We can make it two in two numbers. 2, 3, 5, also 2. Okay, and then for 2, this one was for the present value and future value. How to find future value using the formula and using the Excel sheet function. Same here for present value. For future value of an annuity.
Oh,
yes.
Sorry. I mean,
okay.
Sorry to interrupt you.
No
But
problem.
if you can, maybe you write in Excel, you write again the solution so we can student understand more. I mean, you write by, if you try to write by yourself again one more time. Okay, down there it is okay.
The function.
Yes.
The function here.
Yes, maybe.
Right.
We can use the same data.
We have time.
3%. It is okay. Just.
Okay, we have here. Yes, it's okay. We can add here we have for future value. We have the present value multiplied by 1 plus I to the exponent of n. So it's easy to use it here. Here equal to multiplied by the bracket of 1 plus I. Here I. 1 plus I. This one is the this one is 1 plus I, here the default. Then to the exponent of 5 to the power of 5. This one is equal to 927. This one is the formula, what we use. The formula. Here we use the future value using the function of spreadsheet Excel. So also same, we use future value formula, future value, and both. If you put just the bracket, first bracket, you will understand. You will find rate, press rate, then comma, or we also use here number of periods, 5, number of periods, then comma, then payment. We don't have payment, we said, because it's not an annuity here. So we have present value. So we do just 0, no payment. So we have present value. Then type 0, because in year 0 start, in year 0, or we haven't started for annuity do, we are going to put type is 1, because we receive in the beginning of the period, not at the end. Here at the end of the period type. So okay, at the end of the period, this one we finish it. Then it's look like negative. We explain why it's negative. So similar also for this one. Similar for this one, how to do it. It's not difficult, but it is difficult to use the function, to use the formula of here, formula of an annuity, to use it. Yes, it's also a little bit because of the brackets, so many brackets, to use it in the in Excel. Look at this here. We have 1000 annuity. This is on we call it annuity because it's ordinary annuity. It's not the do. This is the do one. Annuity do. So 1000, 7% interest rate. Here we have number of periods, 5 periods. Look at this. Here we have. It's also difficult to use. You have to try many times. If you cannot do arrange the brackets, you have to arrange the brackets. You count 1, 2, 3, 4. Here until here 4 we have. So you have to use also the same 1, 2, 3, 4. 4 brackets. Divide by 5 for the C5. It's 5 here. Divide by I 7%. Divide by I the interest rate. Okay, then okay, enter. We found here 5,750. Okay, then we use the Excel function. If we just write F V for future value and then do the brackets, there will be appear rate in the beginning, then number of period 5, then we have payment because this is an annuity, so we use payment 1,000. The 1,000 are is payment frequently added to the as periods for each year, for each month, maybe day also. Here also similar number of payment. This one is going to be 0 because we have no present value. We will not consider this as a present value. We use this one as a payment, PMT, payment, not present value. Also here, payment. So the result after we do here, you have to notate. Remember here we have 0, not 1 type is 0 because of we said if the receiving or deposit the money at the end of year, at the end will be 0. At the end of year, at the end of each period will be 0. At the end of each period, 0. At the beginning of the period, we say annuity due. So it's going to be 1 here. 0 is going to be 1 for the annuity due. Also for annuity due, we have different formula a little bit than annuity, the original annuity. So we have another formula. We'll check here. This one for future value, formula for future value. This one is the formula for future value for annuity due. So we have just multiplied by 1 plus I at the end times 1 multiplied by I. The difference is this one, just this amount or this term is the difference between annuity or ordinary annuity and annuity due. Look at this, and this is the ordinary. There is here we have no. For due we have to multiply 4 times 1 plus I for the year, for 1 year, for the 1 period. Not there is no any exponent here. Here 1 means for 1 period, just for 1 period. So we use this here for we will check also. We'll check here. As you see, we have it. We multiply by 1 plus I at the end of the formula here. So it seems same as I explained here. We have so many brackets, so you have to be careful. Or you can use the Excel Excel sheet separate. Here we have future value. Look at this rate, number of periods, payments, and 0 for present value. We have no present value here. We have just payments each year or each period. Type for annuity due is 1. Type is 1 because here in the beginning of each period. So at the beginning of each period is going to be 1 here. Okay, then enter. You will find it as a negative, as I said, because the payments must be negative because of it's considered out cash flow, not in cash flow. In cash flow means positive, so out cash flow is supposed to be negative. Okay, you can also use what I said, the way to calculate individually, calculate all payments individually or separately each year, and there to each other, then you will find the same future value, 5,700 something. Also for this one, for annuity due, you know the difference between annuity ordinary one and the annuity due is just to deposit your payment, the first payment, to deposit it at the year of 0 or today. Year of 0 or today, not at the end of it. Not at the end. Here, the end of 0. Here, the one is the end of first year. But here in the beginning, look at this. Here, ordinary one, annuity is just deposit at the end of first year, at the end of first period. At the end of first period is here. Here in the beginning of first period is in year 0. So why we also here we write type is 1 because of this. And also we have added the term of 1 plus I. For this one is for the year that we have no invest here. This year in the beginning, this one is we receive, we have invested so much will be, and annuity due will be more than ordinary one because we invest here, this one, we invested from the beginning of the period. So it's going to be more discounted and more invested. For future value will be more. For present value will be more also. So same. So here 5,700. So here 6,000 more. So always annuity due is more than annuity the ordinary one or the ordinary annuity because of what we have said is just invest in the beginning of each period. This is the reason. Okay. For present value annuity, we have also here future value, or we say payment, PMT for payment, PMT for payment here. For the present value, we already show you the formula of present value. This one, this formula for the equal payments each period to get the present value of an annuity, ordinary one, this one, ordinary annuity. So we use Excel. In the beginning, we have annuity. We use the formula. Okay, we have 1, 3, 4 brackets. So you have to be careful about brackets. Apply this formula. C4 is the payment. Multiply by 1 minus. Here, as we said, 1 minus for the present value. 1 minus for present value to get present value. For the future value, the term 1 plus something minus 1. So here is the difference. 1 minus 1 plus I to the power of n. And if you do over here or let's say divide by, so this one is going to be not negative, but we use it negative because we get the 1 plus I up in the numerator. In the numerator, 1 plus I in the numerator is going to be in a negative sign. So we write it as a negative, or we put brackets for each for it, and then divided by the also I, divided by I. Okay, and enter. Is going to be 3,116.28. So 700 for 5 years at interest rate 4% is going to be discounted for 5 years, for 5 periods. It's going to be equal to right now equal to 3,116.28. For Excel here, Excel sheet for function with present value rate. So we determine rate, then number of periods 5, Payment, we have payment here 700 because it is an annuity. Future value is 0 because we don't have. Here we have just payment. There is the difference between the lump sum and annuity payment. So many payments each year or each period. So its future value, we have 0, put 0, and type, because it's ordinary annuity, so we put here 0. For annuity due, we put 1. This one at the end of each period 0, but in the beginning of each period will be 1. At the beginning with annuity due, not here. So okay, finish 0 0. After that, enter. So we also find the same calculation, same result of calculation, but it's negative. We also said because of the out cash flow, it's supposed to be negative in here. So now it is here. Also, you can change if you can change 1 or 4 or 3, something like that. The also result will be changed. This is also the Excel Excel feature. If you want to change anything here, years, or so you can change, you can check if it's 4 years, if it's maybe 2 years will be different. So you will check also the result. It is the feature of Excel to check easily. Also here we have the same, but we said if we have the payments, we have here equal payments. If we have unequal payments for an annuity, unequal payments, so we use this way. We just discounted it per period or separately, as I told you before, separately using present value, like this one. Separately we discounted each period, and then find each for each period, then plus to collect all of them, and then 300 the result. So here also you have to consider the if they are equal, you consider the formula, this formula, take in your consideration this formula, or use Excel spreadsheet function, this one. This is just for present value of an annuity or the annuity. For annuity due, it's not so much different, but I told you the difference is to add 1 plus I. To add 1 plus I think we have it here, but this is for future value. Maybe for present value is here. Yeah, this one is for present value. Here, confused. Don't be confused of this one. This one is because of 1 plus R. It's supposed to be in the numerator negative, as I said. So don't be confused about this. Just focus on this one. We times 1 plus I. 1 plus I in the end for present value. But this one is similar to our function. This one here, present value. This is the present value. Same here, cash flow or payments, cash flows or payments. But the difference is to get 1 plus I in the numerator with the convert the sign of number of it to be negative. It was positive down there, so now it's going to be negative. That's it. Don't be confused about this. So just focus on this one. 1 plus I. 1 plus I to be multiplied by all for the whole formula at the end. Here we have it, 1 plus I again. Then we apply this formula, and we got 3,240 using the formula. After using the spreadsheet function, as you see, rate, number of periods, payment, we have it here 700, then 0 for future value, because we have to choose payment. You have either choose payment or future value. If it's annuity, you have to choose payment. If it's not, you choose future value. Now we have also 0 for future value, and type we choose 1 because it is invested or deposited in the beginning of each period. In the beginning of each period, as you see here. As you see here, at the beginning of each period, this is the 700. The beginning is 0. It's different than the ordinary one. 700, 700 each period, but in the beginning. So look at the difference here. It's also greater, as I told you, it's going to be greater than the present value of an ordinary one. So here, greater 3,240.93, as we said here, as we found in here. So the difference is just to add the term of 1 plus I and to put 1 here in the function of spreadsheet instead of 0 for the 0 number. Is there any question?
Okay, thank you. Yeah, thank you. Maybe, dear students, if you have any question, please, maybe you can ask. You can start.
Okay. Okay, we continue to.
Oh, we still have. Oh yeah, okay.
We still have perpetuities. We have perpetuities.
Okay, Doctor, excuse me, Doctor. Maybe
yes.
Because our time maybe is 1 hour and a half. So
okay, that's why I told you.
Yes, okay, sorry. Okay, we still have. I want for actually how to use Excel. It is good to understand how to use it.
I will send also to you.
Easy.
I will
yes.
send.
Okay, thank you. So maybe 5 minutes, then we will start question answer. Okay.
Okay,
thank you.
Okay. So for perpetuities, it's just a perpetuity is as an annuity, same, but the time of period is indefinite. Infinite. Infinite means maybe if we have retirement amount each month might be, so it's going to be continuously paid to you until you die, maybe, or something like that. So this one we call it infinite annuity, infinite or indefinite annuity. We will choose another formula for perpetuity. Here, because we have said cash flows, they are cash for you will be cash inflow, for the bank will be outflow. So the cash is, we have no here 1, 2, 3 number of periods. It's not it's unknown. Number of periods are unknown. So we know we say cash flow or payment, or let's say also each month payment, or each year payment, or each period, divided by I. Divided by I, we didn't consider anything about the time of periods. So cash flow divided by I equal to the present value of a perpetuity. Okay, we have here an example for a bond, perpetual form, a bond, an asset pays how much pays? Think 100 each period. We don't know how many periods. We have just 5% interest rate. So 100 divided over 100 over 5% equal to $2,000. are the payment, or we'll say the present value of perpetuity today. 2,000 today of the perpetuity. Okay, the last topic is the present value and the link with the value of the linkage with the value of a firm. You know, the value of the firm is very important to consider for the managers. Now here we have present value. How we can connect the present value to get the value of a firm? Here we will consider the profitability. Each period, or maybe a year, if we consider it annually, by zero, here this by zero is the current level of profits in the beginning, year zero, because here 1 plus I is 1 plus I, it's its exponent is 0. So 0, the power of 0 is equal to 1. So profit is current profit is is equal to 5, not multiplied by 1 plus I to the power of, or divide by the power of 1. If you make it 1, it's going to be 1. 0 to the power of 0 to the power of 0 is going to be 1 in the numerator, and the denominator is going to be 1. So nothing will be by 0 times 1 times 1. So nothing. This is the current level of profit. So next year or next period, we have by 1 profits. Also next we have by 2 profits, 3 profits, and so on for all periods. So we can find in each point, you can find the present value right now. The present value right now is considered to the firm value. The firm value it is rightly will consider the value of the firm in each point you want. In each point you want to find, you will get. So manager will depend on this one seriously to find the value of the firm. Then they will can maximize their profit accordingly. This one is also, we call it as the impact of managerial decisions. Accordingly, they will maybe maximize their profit if they know the present value today. So present value today of the value of the profits. So they can maximize their value, or the firm value, maximize it using the present value of the current and future profits. This one for the linkage between firm value and present value. And thank you. If you have any question, it's also I will. So let's share the knowledge. We can also learn from each other.
Okay, thank you very much, Dr. Hamid, for your presentation. We have learned many important information today. Also, there is about present value and future value of money. Let's try to see our student. Please, if you have any questions, maybe you can raise hand first, so I can see. I can choose you, or maybe you can ask directly if I see.
You can ask directly, yes.
Okay, you can ask directly from Dr. Hamid. Okay. Do you hear us? Dear students, do you have any questions about present value and future value of money? I don't know if they are you hearing us or no?
Yes, sir, I hear you.
Okay, so I think because we studied little bit about present value of money, and we know some information how to use present value and future value also for firms, and also for what we call but not for annuity, no, but for perpetuities. Maybe we already have some information before. And
for an annuity, you study right, there.
No. Annuity, we didn't study about that, but it is new for them today. But I think the other we studied little information about
Perpetuity.
yes. And also what was also different today, we learn also more a little bit about simple interest and compound interest, because before we just learn how to calculate the present value of money or the future value of money, and how to build our decision based on this information as managerial.
Yes.
But today also we had understand how to make differentiation between simple and compound interest and base it on time. So in simple we just see how many years, but in compound we say there is like maybe we have every month, or we divide year to different periods.
Yeah,
And also like Dr. Hamid talked before, it is important for us to understand the present value of the money and the future value of this money, so we decide what we do with this money. Okay, as managers also we have to understand to take decision based on information, not just like that, or like what you call like gambling. We just maybe we invest or we don't invest, or we do put our money in bank or no, or we buy something or no. So based on information we can calculate, we can understand how, what is the best way to take more benefit from our capital or from our money. And also we understand now how to do this calculation as Dr. Hamid explained before in Excel. It is important to understand the way. We have some examples today, more examples, maybe 12 examples I see Dr. Hamid showed us. We use this in Excel like we do our calculation, like you do sum or you do abstraction or save any simple function. You just write the present value or future value, then you will have that array. You just choose your information and you can calculate. If you don't need to write that what we call like that function, yeah, maybe it will be little hard. But if you use the function from Excel, just equals, then PV or present value or future value, then you will get information how to enter your data by yourself. It is important. Why? Because when you do calculation or when you work, you will not need to give all the time to change information. You just change if the interest rate change or something, you just change information, then you will get the answers. And also we understand also about firm value, how to calculate the firm or company value based on the information from present value of and present income. Yeah, we said this, and I think we studied this also before, how to calculate the firm value. Anyway, thank you very much. Let's see if you still have any question maybe. And I told you from the beginning, if you have any question, you can write down your question, will be easier. So you can ask, don't feel shy. Or I think you understand, or I hope you did understand all this presentation today by our guest lecturer, Dr. Hamid. And I don't know, yeah, if there is no question, so maybe.
Okay. If you want me to explain something more, or I will do. We have here net present value of money.
Oh yes, we still have, okay, maybe because
Still have net present value.
yes, maybe net present value, so we understand how to calculate also net present value.
Yeah.
Okay.
Net present value also similar to present value. It's similar to present value here. Look, present value equal to, we use also same for net present value function. It's like net present value rate, and here we have series of the payments. Here the payments here are not equal as you see. So for you can calculate present value as we found as we calculate here, but here we use the function of net present value, but it is present value. Why? Because we use 0 for the initial investment. We use 0 initial investment. If you use 0 for initial investment in year 0, use 0. So the calculation will be net present value, yes, but it's present value. To use net present value for the different payments, you can use this one for different payments, but you will write net present value to find the present value of the unequal payments each year. That's because we have here put 0, the initial investment is 0. If you want to calculate the net present value, you have to put your initial investment. As we see here, we have put here our initial investment as a negative 1,000, because outflow, out cash flow, our initial investment here, or principal, or what you say, you named it. So here there will be different net present value. We calculate using the function of Excel. First one, rate, and then the series of payments, or the periodic payments, unequal 1, 400, 800, unequal. So to find net present value, what we use it for? Net present value, we use it for to estimate or to predict to your future payments. You calculate your future payments for your project. Maybe here we have initial investment for your maybe raw materials. You have raw materials, you have some equipments you will buy for your business, for your work, your business maybe. Say we have to pay next year 400. Next year we have to pay 800 and something like that. So we just assume we are going to pay like this. Today we talk about this one today, to assume we are going to pay those amounts in the future, and we bought our real initial investment here for raw materials and other things. Then we find the net present value. This net present value will give you the decision to start this business or not. If you want to start this business, it's supposed to be net present value positively, more than 1. Positively. Even more than 1 is not enough. Sometimes they said, the investor said that also more than 0, it's not enough. Sometimes it's supposed to be a good number of amount. If we bought this one is 2,000, let's say bought 2,000, our initial investment is going to be negative. So now the decision is not to go to this business, to this project, because net present value is negative. So it's like that, some they call it capital budgeting in finance. Capital budgeting in finance, we have so many, not just net present value. We have also some other things to make decision that there is a value, to get value from this project, to get profit in the future or not. So you will just estimate. You will estimate your profits in the future. So they will get determined by net present value. Net present value negative means don't go to this project. Negative value positive, yes, go to this project also. It's supposed to be a good amount or a good profit. If it's not like 1,000, we say negative 1,000. Now we can use this net present value as a decision to go through a project or not. That's it, inshallah. If you want me to, if there is any questions, I will answer.
Okay, thank you very much, Dr. Hamid. Dear student, do you have any questions? If there is still any question, yes. Maybe.
If there is any question, if they are understand, okay, I will be happy, no problem. If they understand everything, I will be happy. If there is any questions, I will answer, no problem. I'll try to get from you. And
I think because it is Ramadan and I don't know, a little bit okay. Confusing, yeah. But I hope our student already have understand this is explanation. And
okay.
Thank you very much, Dr. Hamid, for today, and we enjoyed this class. Also for all students, these materials will be available in my class. Inshallah,
I will send to you,
yes, Dr. Hamid will send to me. I will upload for you in my class, and you can read this again. And I hope there is no problem. Okay, that's all about our class today. I would like to thank Dr. Hamid for his coming. Also, Dr. Dimas is already with us today, and all students from IPIEF, IEF. This is I see today we have students from different, not only for semester 6, I think. So we have more students from other groups. Thank you for your coming. I hope you enjoyed this class. And if you also have question or you want materials, if you are not in my class in our group, you can ask me, and I will send you all these materials, or you ask your friends who are already in this group. Okay, that's all. Please don't forget to do your attendance in my class. Again, thank you, Dr. Hamid Wasabi, for today, and we hope to see you again, inshallah. We have this class. Thank you very much.
Thank you. Thank you so much.
Okay, thank you.
Assalamu alaikum.
Alaikum salam
warahmatullahi wabarakatuh. Thank you, doctor.
Thank you.
Okay, thank you all. See you next week, inshallah.
Okay.
Okay, thank you, sir.
Thank you, sir.
Thank you. Thank you so much.
Okay, thank you all. Maybe our admin, if you have, I think you have to. What? We have to leave. Yeah, maybe you can leave by yourself. It is okay. And our admin also, you have to close the door. Sorry. Maybe we can take picture. Where is? I don't know where is admin today.
Okay.
Let's before you go, please all. We have to take picture because this admin should ask this. I don't know. Take picture. Let's
okay.
We can do screenshot. It is okay. Please, all of you, if you have your camera on, and turn on your camera, please. And we take one picture for this class today. Okay. Well, we lost maybe 10 students or 15, but it is okay. Okay, Mr. Burhanuddin already here, Mr. Adisina, and please, other Nana, Inda, Norol, Amirul. Okay, because this comes suddenly, we ask to turn on your camera. Maybe we have to give them time a little bit. Please, if you can, Mr. Who else? Okay, Aji, Bira, Dimas.
Yes, sir.
Okay, Mr. Dimas, your camera, turn on your camera. Could you? Okay. Looks you are still sleepy, Mr. Dimas. Okay, anyway, thank you very much. We cannot do more than this because maybe they were not ready, so we will not take more time. Dr. Hamid, thank you very much.
Thank you.
Okay, I have take one screenshot for all. I will send you in WhatsApp. Okay, thank you very much all.
Thank you.
See you next week. Inshallah, Dr. Hamid, we keep in touch. And
we keep in touch, inshallah.
Yeah, thank you very much. Goodbye.
Goodbye.
You can leave the room. You can leave the room because I cannot close this. You should leave the room by yourself. And I think it's still live on YouTube also. Please, our admin, you can, if you hear me, our admin, please, you can end our meeting for today.